Great. So in my time at Tippecanoe and throughout my career, I've done a little bit of this and a little bit of this, quite a bit of this, and a little bit of that. And I'm doing it right now with a great company called Tippecanoe, where I'm the project manager for our mobile development team. For those of you who haven't heard about Tippecanoe and the kind of work that we do awesome. But really the type of work that we do on the mobile development team is we've been lucky enough to build the #3 free iPad app in the App Store, the #3 free overall app. Got a brand new app out there that already has hit 500,000 downloads. And one of our more mature applications just crested 1 million downloads. But the really reason that I really enjoy working at Tippecanoe is that developers get a lot of respect. So about 3-4 months ago, when I switched my sort of full-time development part of my job to doing Android development, I really got the opportunity to go back and sort of look at everything that we were doing previously and look at all the kind of new tools that were out there for Android development and really more or less start from scratch or really kind of reevaluate everything we were doing previously. And I think a big part of that was all the previous languages that I'd been exposed to and all the previous techniques that I found really useful in those languages. I started looking for, well, what's the Android equivalent of technique X or technology X? And I found that in sort of the existing stack, there weren't a lot of these parallels for things that I'd come to expect as kind of indispensable parts of any framework or any language. Of course, developers. But I think that at the end of all that research and sort of all that preparation work, I've got something to say about modern Android development. You're probably doing it wrong, but don't worry. Tonight we're going to look at how you can do it better. So tonight we're going to talk about 3 things. First, we're going to discuss the current state of Android development and why I think we are really in need of a new tool set and some modern tools. Second, we're going to look at what these new tools are, what's out there, what's coming out, sort of the cutting edge of what we can do in Android development. And we're going to wrap up with something that I hope you can all take home, take back to school, take back to your jobs or to your hobbies, and really make use of the content tonight. So first off, the story so far in Android development. In the beginning, we got Eclipse. It's an IDE built for Java. It's slow, it's crashy, it's got kind of weird integration with the Android tool set, but it's not designed from the ground up for Android. And I think anyone who's used it, anyone who's using it now, that's kind of painfully obvious. We've got a really, really slow emulator that doesn't work very well. It takes up a ton of resources, and it's really not very practical to debug things in. We got this thing that you do something with. I don't really understand what this is meant to practically teach you about your application. And seriously, if anyone understands how to work with the memory profiler in the Android tools, give a talk on it, because I don't understand it at all. I look at these graphs, I look at this list of numbers, and all I want to know is, am I leaking data? Am I retaining things too hard? And I have no idea how to work with this tool. And then for a really, really long time, nothing happened. Not a thing. And in fact, that's probably where most of the people in this room are at, is still using this existing tool set. And that's really a shame. Now, meanwhile, across the hall, the other kids were getting really significant tool upgrades. Every new iteration of iOS was matched with an upgrade to Xcode IDE, built from the ground up for Objective-C development in the Cocoa framework, designed solely to build the type of apps that you build in it. All the tools are built exactly for the purposes that of iOS and native Mac development. They got access to this really killer storyboarding system where you can do kind of rapid prototyping, see your application, and kind of build the stubs of it. Really, really handy. They got this really neat way to look and analyze your code where it draws these arrows all around and shows you, where you might potentially run into problems way before you even run your code. Great static code analysis tools. They got a memory profiler that's really, really easy. It runs, as you're running your application, you can pause it, you can see exactly when things are leaking, you can trace it back to where it started. And I think most importantly, the community really came together and built this tool called CocoaPods, which you can think of like Gems from Ruby or Composer from PHP. It's sort of a dependency management and code sharing system. Now, personally at this point, I kind of wish Google would give us a little less skydiving, a little less self-driving cars, and a little bit more meat in my developer tool chain. I think we should kind of feel betrayed as developers at this point. We should really be mad as hell. But I think the positive way of moving things forward is to become early adopters of what I see as a better breed of tools. Which brings us to our second topic of the night. We're going to look at what are these new tools, and where do they fit into your workflow as an Android developer. So first, a note about the B word. A lot of developers are really wary about switching to these tools because they're labeled as beta versions. Remember this beta that no one used because it was slow and it crashed and it didn't work very well? Or this one, I don't know a single person who used this to get home or find their way. No one sure used this browser, it was a beta, totally useless. My point being that we really shouldn't fear the beta tag. Beyond the fact that Google seems to really not understand what that word means, I'll give you 13 really, really good reasons why you should trust Android Studio. And those 13 reasons are the 13 versions of IntelliJ IDEA that Android Studio is based upon. This is a really mature, feature-rich project. It's been in use for a long time. Android Studio stays up to date with bug fixes, feature pulls. Right now, they're totally up to date with version 13, and basically getting a $900 piece of software for free, more or less, in the Android Studio. So let's take a look at the 3 new faces of our modern tool set. First, your new IDE, Android Studio. This is replacing Eclipse. Second is Gradle. This is your new build tool. This is going to replace Ant. And third is Maven, which is something brand new to, I think, most of us in Android development. This is going to be our dependency management tool. So let's start off with Android Studio. Take a look at some of the reasons that I think it's awesome. The source code that's going to pop up on the screen here is a library that I created and open source called Section List View. I'll show off a little bit more of that later and kind of what that library does. So this is Android Studio. And I'm just going to go real quick here through a couple of things that kind of make it awesome. So it's integrated Android from the ground up. You've got these kind of awesome wizards for building the pieces of your application that there's a lot of boilerplate code involved in. You can create services straight from the ground up. You can create fragments. If you want a fragment with a list in it, there's a wizard to build that. You want to build activities with fragments in it. If you haven't rolled fragments into your existing workflow, that's right in from the ground. You'll never build an activity without building a fragment. Again, you just don't have to think about it. It'll create the views for you, it'll create everything. It's got this great indexing search thing. So you saw me there, fire open, just the name of a file, it'll open it up. You can search for classes, you can search for pretty much anything. It's just fast, jumps you right to exactly where you want to go. It's got integrated support for Gradle and Maven. So you'll see here that I can go and add a dependency, and there's a nice GUI here. It'll browse the publicly available Maven dependencies. I could choose a package, choose exactly what version you want. Boom, there it is. It's part of my build now. For any of you who have used the layout builder in Eclipse. It's really slow and kind of doesn't render properly sometimes. I found that the one in Android Studio is awesome. I spend more time probably doing the GUI editing than I ever have before because I can trust that it's going to work. It'll do all your alignment stuff. It's even got awesome stuff like this. Like it added a label, it added a hard-coded string, and it warned me, hey, this hard-coded string, you should probably extract this right now into a strings.xml file. Gives you a GUI to do that, and it's done. You just don't have to think about it anymore. They've got really awesome refactoring tools. I've only scratched the surface of this, but you can do all sorts of stuff. You can extract your inner classes up into a new file. You can move them between the files. They'll kind of go through and warn you. Here I'm changing the signature interactively of a method, and you'll see in a second, I'm adding a Boolean, giving it a name. I can even give it a default value, and of course there are no default values in Java. So it'll actually go through every usage of that method and inject that default value. Here what it's doing is showing me, hey, if you were to make this signature change, here's the stuff that I would update for you. Here's the changes that I would make. So you can kind of get a preview of the magic that it's going to do. This is going to be a little difficult to see, but they just recently pulled a feature from Sublime Text Editor, the kind of really cool multi-line, multi-cursor editing. They just added that this week in the update. You're pretty much getting weekly updates to Android Studio at this point, so it's just, yeah, why not? Let's add it in there. It's a great feature. Similar to the iOS stuff, Android Studio's got really, really great static code analysis right when you're editing your code. So you can see I added a stupid if statement here, if false and something else. So it's warning me, it's like, I don't understand what you're doing. Here's all the way that you could fix your stupid code. And it'll just, you choose one and it's done. But it recognized that I did something I probably didn't mean to. It can analyze through an index your entire dependency graph and let you browse through every object, every class, every method, and find out if you were to, extract something, if you were to refactor something, how big of a change would this be, and how many lines of code might I have to touch. So you can see here I'm kind of going through the different components of my application. This method uses all these different things. It's dependent on them. It's just a really nice way of getting sort of an upfront view of how complex your code is and how costly any change is going to be. This is something that is in Eclipse, although I find it works way better in Android Studio, and that's the lint processor. It's actually a command line tool. You can get a static report of it, but it'll analyze your code, go through and find all sorts of errors, literally like hundreds of different types of errors. Some of them are really superficial, and some of them are really intelligent errors. I had it come up with an error once where I had a method that had parameters called width and height, and I was passing a variable that had the word width in it to both of them, which I did mean to. I was trying to make something square, and it was like, this thing is expecting a height, but you gave it something that you kind of called a width. Did you really mean to do that? Because you probably didn't. So you can see the error that it's come across here again is another one where I've got hard-coded strings somewhere deep down in my XML file. I can choose which strings.xml I want to refactor that into. It'll take care of it all. It's one shortcut key away. Really great. Got built-in support for version control, Git, SVN, CVS. Really nice stuff for GitHub and Bitbucket. It's all built in. You can commit, do your diffs all within the same tool. And anyone who's used whatever that Git plugin for Eclipse is, that one's pretty terrible. So this is what I use for all of my merges. You can do this really cool reformatting right before you commit. Rearrange your code to do whatever you want. Put the public methods followed by the private, followed by the static, or whatever order you might want to go in. It can reformat your code, so if you like your braces on a certain line or whatever, you can do that all right as soon as you commit. It's just part of your workflow. You don't have to think about it anymore. So that's just a couple of the reasons why I really like Android Studio. Second piece of our modern toolkit is Gradle, our new build tool. Gradle's incredibly powerful. It's actually, you can write programs in your build script, and I'll just give you a really simple example of that. I wrote a small program in the language that Gradle uses called Groovy, where every time we're doing a build that's signaled as a release build, it'll interactively ask me where my key store files, what my key store password is right from the command line. So it ensures that if I'm not building a signed release copy, that I really mean to be doing that. If you're running OS 10 and you've got Homebrew installed, installing Gradle's dead easy, one command away. But you don't even have to do that. The easiest and best way to work with Gradle is to have each project use its own installation. It's called a wrapper. It's just a small binary file. Gradle itself is small enough to just be one file. You can commit it up to your version control if you want. And the nice thing about this is it means that all of your applications can use a different version of Gradle. If there's, if there are incompatibilities moving forward, things change. You don't have to worry about it. This is a real nice thing that you can do with Ruby as well, but some of the bigger projects, keeping multiple installations of PHP around is a real pain sometimes. So I'm going to show you here in that same library a couple of the different aspects of Gradle. So first off, you've got a settings.gradle file. This is sort of at the root level of your project. It shows you all the modules that are going to be included in that project. So in this one, I've got 2 modules. You've got a project level build.gradle, which is sort of your global scope of the entire application and all the formats that the application can take. Typically, you don't do anything in here because you don't build the entire application. You build one particular module, and maybe that module builds another one as part of it. You've got a Gradle wrapper.properties file. This is what I was talking about. This is where you just tell the Gradle wrapper, hey, I want to use this version of Gradle, and it'll download the jar for that and take care of it. And then you've got your module level build.gradle file. This is sort of really where the guts of things happen. You can see here that I'm listing like a couple dependencies. I've got a couple small instructions for how to upload the archives. And this is another module, its build.gradle file. So each module in your application can have different dependencies. In this one, this is a library that I wrote. So one of the modules in there is the library itself. One is an application, and of course the application has a dependency on the library internally. So it's just a nice way to think about your code. If I wanted to pull one of those out, it wouldn't be a giant refactor. It would literally just be taking that directory and moving it somewhere else. Gradle's built into a set of tasks. So if you run this command within any Gradle package, you'll get a list of all the stuff that you can do. Typically, you don't need to worry about any of these. They're all kind of wrapped in the build in Android Studio, but if you want to execute any of them from the command line, you can. So this is an example of just showing you what that list of tasks for one of my libraries looks like. You can see here I'm executing the Gradle W, which is that Gradle wrapper, and I'm just giving it that command that I had on the previous slide.
Java.
What's that?
Knock, knock. Who's there?
Java.
Java.
Okay. So yeah, so this is the giant list of all the tasks that I can run in that library. There's tons of stuff here, but the important thing is you can execute all these from the command line. There's no IDE involved, there's no extra tools. So your continuous integration environments, Jenkins or whatever, your setup for that just got a whole lot easier because you don't have to worry about booting Eclipse or booting that environment. It's entirely self-contained. And the last piece of our new toolkit is Maven, which in and of itself is actually a full-featured build system. Gradle has kind of replaced most of it, so the only piece that we're going to use from it is its dependency management system. Again, if you're running OS 10, you got Homebrew installed, Maven's one command away. And in a build.gradle file, Maven lets you do stuff like this. It lets you list off your dependencies. So here I'm including 3 libraries. 2 of them are the different versions of the Google support libraries, and the last one's a library that I wrote. You notice here that you can give it a different version number for each of them. You can even do things like have a plus sign in here. So if I went 0.0.plus, it would go 0.0.anything, and it would just give me the latest version of that. So you can do things like, I want version 1, but the latest version. I don't want to go to version 2 yet, but just give me the latest of version 1. And of course, these all could possibly have transitive properties in them. In fact, my library has dependencies on 3 libraries internally in and of itself, but you don't need to worry about that. So the days of copying around jar files and, oh boy, this one needs this other one and I got to no, it's a different version for this. You're just working in the actual dependencies now. So there's kind of 3 ways of actually working with Maven or actually managing Maven dependencies. You've got the first one, which is Maven Central. Most packages are available in Maven Central. It's kind of the most popular spot for packages. The second one is a system we're using. There's a few alternatives to this, but it's a program called from Apache called Archiva. What this lets you do is host a private Maven repository. So we're doing this at Tipping Canoe for some of the projects or some of the libraries that we're not ready to open source yet, so we can ensure that only our developers can access it. We run it on one of our servers. And the third one, which I'm a big fan of, is kind of abusing how GitHub works. You can actually run a Maven repository right in a GitHub project. So I'll show that off. But the real important thing, I think, right now is because these are kind of the cutting edge, any one of these 3 things, looking at whether an Android library is available in Maven is really a good litmus test of how well maintained that library is. I find that this sort of strategy of looking at it, and is it only available in a jar download? They probably haven't touched it in 8 months to a year now, and that's probably a pretty good example that this really isn't being maintained anymore. So let's make sure we tell things like the Facebook SDK and Google Volley that aren't available in dependency management and are only jar downloads that they got to get with the times and get with one of these. Now, of these 3 things, or 3 ways, I don't know how Maven Central works. I don't know how to upload to it. There's lots of instructions online. I've never found a reason to do it. I guess because none of the libraries that I've written, I feel, are like 1.0 ready yet. They're all pretty experimental. But the other 2 I'm familiar with, so we'll walk you through that really quickly. So first off is Archiva, which again is your way of hosting a private Maven repository for your company. So the first thing you're going to want to do here is edit this file called Gradle.properties. And what you're going to want to stick in there is your credentials for Archiva. The key Maven user, Maven password, those could be whatever you want. They're just key value pairs. Then in your project's build.gradle file, you're going to give it some meta information about your library. You're going to apply the Maven plugin. You're going to give it a little bit of data there. And then the kind of meat and potatoes here is in this command upload archives. So you can see basically what it's doing here is it's using all that metadata and it's telling it to upload it to myarchiva.domain.com. And it's using my authentication as that key value pair that we can configure in that file. Sorry, I think I forgot to mention, this all is only if you're actually developing libraries. To use Maven libraries, particularly ones from Maven Central, you don't have to do any of this. You just list your dependencies and you're good to go. But the way that I really like working with a Maven repository for stuff that I'm open sourcing is, as I mentioned, you can kind of just abuse a little bit of how GitHub works internally and get away with hosting stuff right within GitHub. Really very easy. So you don't need any setup, no usernames, no passwords. All you do is give it the upload archives command, and you can see what I'm doing here is I'm telling it that there's a repository that's just on the file system, and it's just 1 level up in a directory called Maven. That name Maven, that could be whatever you want. I just call it Maven because it is my Maven repository. When you execute a upload archives command, you can see it's doing exactly what we told it to in that command. It's creating that directory called Maven, and it's inserting a fully functioning Maven repository in that directory. Now, the real magic comes when you upload that to GitHub. When you want to use that library, you just give it the URL raw.github.com, and then the path to wherever your repository is, /master/Maven. And again, Maven's just the name of that directory actually in the file system. So we've got all these great new tools to make code, and we've got these great mechanics to consume other people's codes. But if there's one thing that I really want everyone to kind of take home is the desire to give back and to share their own code and share their own libraries. So I hope that this is the command that everyone here is executing the most often. This is the command to upload your archives to signal that your code's ready to share. And if you don't think that you've got anything to share, the last thing we're going to talk about tonight is building your first Android library. Something we've kind of started at Tipping Canoe. It's the way I kind of start every language. The library that I work in is some variation on this theme. It's just a junk drawer. It's just all the static little functions, all the lines of code that you had to look up on Stack Overflow, and you have to look up every single time you want to run them. It's 5 minutes wasted every single time, so if you can wrap those in a syntax that's easy for you to remember, it's just absolutely a win-win. Plus, you can't overestimate the fact that when you go to build your next application, you find a bug in one of those methods, you go back and fix it in one spot, do your build and your Gradle, all those dependencies get copied over into all your applications. They're all suddenly up to date with these bug fixes. The code that I'm going to show off is available on GitHub in the Winnipeg Android group, so you can check it out there when we're done. So this is the process of building Junk Drawer. So you create a new project, give it a name called Junk Drawer, give the module a name. I'm calling the module the library. You could call it whatever you want. I don't need an activity because there's no views involved in this project. It is an Android library, so I'm going to mark it as such. It's going to go ahead and build out all the directories for me, build my Gradle, download the Gradle wrapper, do all the sort of project setup that I need to. All right, so we're going to open up a couple files here that we're going to need. First, we're going to need our build.gradle file. And second, we're going to need to create a new class. One thing that I think is a bug right now, or maybe just a bug with how I installed Android Studio, whenever I do a new project, my Gradle wrapper doesn't have the proper permissions, so I'm just chmodding it 777 there to make it executable. Otherwise, I can't run it from the command line without going to sudo. So I'm creating a new class here. I'm just going to call it dimension helpers. This is just going to be a collection of static functions to help you do stuff with dimensions. We're going to build a new constructor here. We're going to change it to being a private constructor because, as I mentioned, this is just going to be a collection of static functions. We're not going to really need to instantiate objects of this class. And the method that we're going to show here is a public method, public static, float. How many times have you guys looked up how to convert pixels to density independent pixels? I look it up all the time. So we're going to write a tiny little method here. Never have to look it up again. You just execute this function. It does whatever you need. Context, and you need the DPs that you need to convert. So this is a little snippet of code. Does something with a thing called typed value, and you apply the dimension and you return it. I don't know, this is what I got off Stack Overflow, so I copied and pasted it in here again here. I don't need to ever look it up again. Of course, we're good developers, so we're going to go ahead and document our function nicely. So yeah, so this method is just going to take a supplied density independent value and give us back the pixel value. I had to record this about 12 times last night, so if it seems like I'm typing very slow when I was recording this, it's because I'm making sure I don't make any mistakes. So that's it. That's our function. That's our static function. Last piece we need in here is that little snippet of code that I showed a couple of slides earlier, how to upload in quotes, to GitHub, to that Maven directory in your GitHub project. So that's it. We're going to pop open terminal. By the way, there's a terminal built into Android Studio, of course. You don't have to open another window. We're going to execute that Gradle W build upload archives. So it's going to go through here. It hasn't done it before, so it's a little slower than normal. But it's going to go through all the stuff that Gradle does for you, all the stuff that that build command does for you, which is a lot of those tasks that we looked at earlier. It kind of bundles all those together in one, and boom, there it is. So if I refresh the file system, which Android Studio calls synchronize, which whatever. There's that Maven directory. Here's my library in Maven format. You can see Maven actually uses a format called AAR. AAR is slightly different than a jar. It's an Android archive resource as opposed to a jar. It bundles together the assets and the manifest and all that stuff into one file format. And then the last thing I'm going to do is go ahead and commit that up, enable version control for Git, and commit it up to GitHub. So the final thing I really want to talk about is just to let us inspire each other. I think that obviously that one line function in here is just the start. At Tipping Canoe, our junk drawer probably has about 30, 40 static functions in there. I'm hoping to open source it, just got to sort of ask for permission because anytime I write something on company time, just make sure that there's nothing private in there before I go ahead and stick it up. But it's really an indispensable tool. We've got stuff in there. You know, again, anytime I look up something on Stack Overflow, I stick it in the junk drawer. How do you show and hide the software keyboard? I had to look it up. It's in the junk drawer. It's one line of code now. How do I create an intent to open a URL? It's in the junk drawer. Just provide it the URL and maybe a context or something. It does whatever it needs to. And so we sort of abstract all the, you know, if build version is greater than Jelly Bean, then do this. You know, it's one level even above wrapping that in a class in your application. It's in a class in a totally different application, which is your junk drawer library. So the last thing that I want to show is some of the stuff that I've been working on beyond junk drawer to kind of give you an idea what the next level beyond sort of that basic is. But Velociraptor has something to say about this kind of wishy-washiness. The first thing that I've built is the most experimental. It's a library called Annotations. I'm a big pun guy, so yeah. So this brings traits from PHP, or I think mixins from Ruby, into the Java world. And it does so by using annotations, which are a feature of Java. It's a static sort of compile time thing that actually generates code at compile time that the rest of your code can use. I say it's experimental because I wrote it and I haven't used it yet, so no one's used it yet, but in theory it should be usable. Second one we're definitely using, this is something called Object Cache. This is something that was really kind of born out of necessity of something I found myself kind of doing over and over again. A lot of the work that we do is based off results from a REST API. And we sort of always know that the results of every network request we do are valid for some length of time. Usually it's like, we only want to refresh this content once a day, once a week, once a month, something like that. We don't want to, every time the app boots, have to download this content that's really the same all the time. So this is a library that lets you stick any plain old Java object into a cache along with an expiry time. And every time you read the value out of the cache, you get sort of a signal. You either get the object back out of the cache, or you get the object and a signal that it's about to expire, so you should trigger the refresh sequence, or you get an error that the object wasn't in the cache, in which case you should download it and put it in the cache so that the next line of code can receive it. So this is an example of how that library kind of works in practice. This is an application we're working on right now for a German travel website. But all these categories along the left-hand side there, those are things that our REST API serves up to us. They don't change all that often. They haven't changed in the entire time that we've been working on the application. But it's still a good idea that we don't keep them around forever, because then if they choose to add one or fix a typo in one, we have to release a brand new version in Google Play Store just to fix something as trivial as that. So I download those ones, stick them in the cache with a flag to keep it in the cache for a month or a week or something, and I save myself all those additional network requests to download that every time the app boots. Second one is just something that exists in iOS and I can't believe doesn't exist in Android, and it's to have a list view with sections in it. They have a list view with collapsible areas, but not one that I think kind of works like this. So easier to show it in action, but as I scroll down, this is a list view. This one's going to get stuck to the top. This is a section, and as soon as we get to the next header section, it's going to push that one off the top. So you have a list view with sections. So you don't need to manage that. And when you're doing your, get view for position, it's no longer just get for view for position. It's get view for position in sections. So your code kind of works with those sections. Each section can optionally have a header. Each header can optionally be stuck to the top, like the tabs are here at the top. And it's really efficient. It actually draws bitmaps straight onto the canvas. It doesn't duplicate the views. So it's pretty nice. So what did we look at? First off, we looked at the story so far, kind of where we are right now with Android development, and why we deserve a better breed of tools to do our Android development. We looked at Junk Drawer, which I hope some of you guys go home, commit your own lines of code, commit your own static methods up to that. If you need help with how to commit to the Gradle or commit to the Maven repository in GitHub, just shoot me an email or a tweet or anything, and I'll help you out with that. So just to finish off here, yeah, I really want us all to work together because I think our code becomes much more awesome the more that we're sharing, the more eyeballs that are on our code, the more people that are kind of looking and thinking and talking about our code. To hide our code away in jar files is really just not the way to go. So I'm hoping that the Git repository stops looking like this after tonight. Starts having a little more of this. And this. And these guys. And these guys. And everyone.
Very good.
Anyone have any questions? There's obviously a lot to take in there. It's a whole new kind of way of thinking about your stuff, a whole new way of thinking about your code and thinking about your applications, as well as a whole new tool chain to support that. Yeah?
Do you have any experience trying to switch between Eclipse projects and Android Studio projects?
Yeah, I migrated our largest code base from Eclipse to Android Studio. Was sort of the first thing that I did when I started this. And so it was that combined with learning all this from the ground. So it was basically me locking myself in a room for 2 weeks and kind of figuring it out. But I think I learned a lot. And the kind of the sad part is when you start looking up how to do a lot of this stuff online, you're not going to find a lot of information. I think a lot of people are pretty happy right now, kind of with, in my opinion, kind of with their heads in the sand with the existing tool set. It's kind of good enough. Yeah, I think Android gets saddled with a lot of weight from Java and this kind of big enterprise Java world that really we don't need to be part of. We share the same language, but kind of need our own tools to do our own thing. Yeah.
What about AntScript? Like, is it compatible within Gradle in any way? Like,
I don't think it's compatible with Gradle at all. Yeah, and I mean Google kind of, if you go to the URL for Gradle build, the URL on the Google code site is whatever /new-build-system. They haven't bothered giving it a name Gradle yet, but I think the writing's on the wall that Ant is going to slowly be deprecated by Google, and at least Gradle will have feature parity, if not be the total way forward in a couple of years, yeah, or a couple months, I hope, yeah. Yeah.
Remote testing.
Sorry?
Remote testing.
So testing is obviously something developers hate doing, even though we all should be doing it. So I think the this week's build of Android Studio, literally we're getting kind of weekly updates at this point, fixed some stuff with running tests from Gradle. I haven't bothered to go back and look because the previous answer was it kind of works from the command line. There is a command to execute tests, but it doesn't work from within Android Studio yet. But I think that's what they fixed this week. So it's clear that they're going to improve it rapidly as often as they can. But yeah, I mean, the nice thing is your tests would just be another module that you could optionally include with Gradle, and of course, there's no risk of you compiling those tests into your production APK or anything like that. It's much nicer to segment it out that way once they do get everything working. Yeah, and again, I think like they literally added it. I saw in the update last week that they did something about it. So that's the next project. Once we get done that application I showed, kind of our next thing is to get all of our acceptance tests booting again in Gradle, because it was something that I set off to the side and figured I'll come back to on a rainy day. But yeah. Okay.